In this video, we want to solve some logarithmic equations. We're going to use some properties of logs. So there's 4 equations there. And here are the properties that we'll be using. And to give information, A, B, M, N are real numbers. A is positive, not equal to 1. B is positive, not equal to 1. M positive, and N is positive. I'll look over the main ones that we'll be using. Of course, you have the definition of log. The log of x to base a equals y means x equal a to the y. So we'll have just a brief review here. So if I give you what is the log of 8 to base 2? This says the log of x to base a equals y means x has to equal to a to the y. So this is equal to 3 because 8 does equal 3 factors of 2. Just a brief example there. The log of 1, of course, to any base is 0. The log of a to the a is equal to 1. And some property dealing with inverses of logs and exponentials. The log of a product can be written as the sum of the logs and vice versa. So if you're given the expression on the right side, the sum, you can write it as the log of the product of these values, m and n. The log of a the log of a fraction, m over n, to the base a, can be written as log of the numerator, m, minus the log of the denominator, n, with respect to the given base. If you're given the log of m to the r power to base a, you can bring this exponent as a coefficient. Works both ways. So if you're given the first expression on the right, you can write it like the one on the left. If you have the log of m and the log of n to the same base, have to be equal. You use that when you solve equations, of course. And then, of course, you have your change of base formula. We'll be using that. If you have the log of m, we'll make up an example here. If I have the log of, say, 77 to base 5. Okay, here I can't do like the one I did a while ago. I don't have an exact answer for this one. So I'd have to use a calculator and the change of base. So what I would do here is I would change the base to something that I have in my calculator. And most calculators, scientific calculators, you'll have the log to base 10 and the natural log, which is to base e. So here you can pick any one of those. I usually pick the natural log. So to do this in the calculator, I would just enter natural log of 77 over the natural log of whatever the given base is. In this case, it's 5. And then I would just use my calculator and run it out as indicated. Okay, so hopefully you already know some of those things here. But let's start with the first one. Have the log of x plus 6 equal to 1. There's no base indicated. That always means it's base 10. You don't have to write it in there, it's understood. But generally when you solve log equations, basically you want the equation as a single logarithm, which I have. Because then you can use the definition that tells you that if you have it as a single log, this expression x plus 6 has to equal to whatever the base is. In this case, it's understood to be 10 to whatever this value is, the power. So 10 to the first. X plus 6 equal 10 to the 6. I'm sorry, x plus 6 equal 10 to the first. Subtract 6 from both sides. You get x equal to 4. You can normally check these by just plugging back in. 4 and 6 is 10. 10 to what power? Gives me 10. 10 has to equal to this base taken to that power, and it does. 10 equals 10 to the first. That's your quick check on that. Now, if you have 2 logs, again, what I want to do is write this as a single log. So if I have the sum of 2 logs, I can write it as the product. But you have to be careful with the coefficient. So this has a coefficient of 3 here, so we have to take care of that. This is where we use the property of logs. We're going to put this one up here first. Now I can say I have the log of x minus 1 to the third plus the log of 4 to base 2. And I could write this as the log of this times 4. One way to do it. But since I just have numbers here, I could just say, well, log of 4 to base 2, that's 2. Because 2 to the second power is 4. and then subtract 2 from both sides here, I get the log to base 2 of x minus 1 to the third. And that's going to equal to 3. So now I can write this as a exponential, write it in exponential form, go from log to exponential form using the definition. This means that x minus 1 to the third, that's this expression here, has to equal to whatever the base is, that's 2, to this power, which is 3. Okay, 2 to the third, that's 8. So now you just solve this equation. I got x minus 1 to the third equals to 8. Take the cube root of that, cube root of both sides. So cube root of this side will just give me x minus 1, and the cube root of 8 will just give me 2. Add 1 to both sides here. We get x equal to 3. Now let's check it. Put a 3 here. So 3 minus 1 is 2. So the log of 2 to base 2, that's 1. And then multiply by 3. The log of 4 to base 2, we said that's 2. 3 and 2 is 5. That checks. So the answer to number 2 is x equal to 3. Now for number 3, notice the base is a, so it's not given. So that means you don't need the base. It could be any base. 2, 3, 4. It's still going to work. So like I said, normally when you're solving an equation, it's easier if you have just a single log. So using the properties, most cases you can write it as a single log. So notice right here, I have a difference on the left side, difference of 2 logs there. So I'm going to write that as the log of a fraction. So I can write that as the log to base a of x minus 1 over x plus 6. X minus 1 over x plus 6. X plus 6. Now on the right side, I got the difference of 2 logs again. So I can write that as the log base a of x minus 2 over x plus 3. Now I could go further and bring this log to the left side and make that a minus, and then I would have this quantity over this quantity, the log of this quantity over this quantity, but that gets kind of messy. So if you can get it where you have it isolated, isolate the log on one side and isolate a log on the right side, as long as they have the same base, in this case I have base a, then this expression in the parentheses here has to equal to that expression right there. So you just set those equal, and then it becomes a regular rational equation. X minus 1 plus 6 is equal to x minus 2 over x plus 3. Now we have to solve this. The easiest way to do this is to cross multiply. You can multiply by the LCD, which is x plus 6, x plus 3, but it also just multiply across this way and this way. So x minus 1 times x plus 3. Multiplying 2 binomials, so that'll give me x squared plus 2x minus 3. X minus 1 times x plus 3 is x squared plus 2x minus 3, and that's going to equal to the cross product the other way. So x plus 6 times x minus 2 will give me an x squared plus 4x minus 12. And now we have, looks like a quadratic equation, but when you try to collect your terms, bring everything to one side, the x squared and the x squared cancels, so it's just a linear equation. So let's bring this 4x over to this side. So minus 4x and a 2x is a minus 2x. And take this minus 3 to the right side, becomes a plus 3, minus 12 and a plus 3 is a minus 9. And we divide by negative 2. So this cancels out, and we get x is equal to, the negatives on the right side cancel out, so we get 9 over 2. One tip to know here when you're solving a log equation, you don't really have to check it. Like in this one, it's going to take a little bit longer to do it because you have a fraction here. It can be done. But if you're taking a test and you're in a rush, you can do a quick check this way. The log of a negative number is not defined. The log of 0 is not defined. So this quantity here in the parentheses, or here, or here, or in this one over here, has to be a positive number. So if you know you did this algebra here correctly, just right there, just put it in mentally. 9/2 is larger than 1. So 9/2 minus 1 is positive. 9 over 2 and 6. Of course, obviously, they're both positive, so that checks. 9 halves is larger than 2, so 9 halves minus 2 is positive, no problem. 9 halves and 3 is positive, so that checks. 9 over 2 is the answer. Now in the last one, we have different bases. Now sometimes you can figure these out mentally. Notice here, if I let x be 1, put 1 in here, the log of 1 is 0 because 4 to the 0 is 1. So this cancels out. I put a 1 there. That gives me 1 and 1 is 2. The log of 2 is 1 because 2 to the first power is 2. There's your check. So the answer is 1. But sometimes you don't see it, or you have a more complex equation. Now that's the way you could do it if you're in a hurry. But if the teacher wants you to show the work, he or she may not give you the credit or whole credit. But here's the way you want to do it. We're going to get the same base. So I'm going to leave the first one the way it is. And I'm going to change the second one to base 2. So I could change this one to base 4. But I do this one. So what I'll do is this. This will be a minus here. And remember the way it works. I take the log of this expression to some other base. Normally you use base 10 or natural log, but here, since we're working this equation, we need base 2. So I take the log actually of the x first. So it's the log of whatever this is. In this case it's x to the new base. And the new base is going to be 2 because that's what the first one is. We want to get them the same. So this will be 2. So then it'll be 2 base 2, log of x to base 2, and then it'll be the log to base 2 of what the original base was. There it is. That's 4. And what is the log of 4 to base 2? Well, this is 2, because 2 to the second is 4. And we get the 1 here. So now what I'm going to do is I'm going to multiply both sides of the equation by 2. So that'll put a 2 there. So this will be 2 log the base 2 of x plus 1. And multiply by 2, well that's going to cancel this here. Just give me the numerator then. This will be minus log base 2 of x. And this numerator cancels, or this denominator cancels because it was 2. And we multiply by 2. And multiplying the right side by 2, that gives me a 2. 1 times 2. Now, I'm going to be working with these two, making this into a single expression. But to do that, I have to get rid of this coefficient. So I'm going to bring this coefficient here and make it an exponent. That's one of the properties that we had in the first part of the video. So this will be a 2 here then. Now this 2 comes here as an exponent. So then I'll just delete this one here. We have that. Now here's where I use the property. I have a difference of 2 logs. So I'm going to have the log base 2 of this expression here over the expression there x. So this will be x plus 1 to the second over x. And this is equal to 2. So now this expression right here is equal to this base taken to that base. So this will be x plus 1, the second power, over x is equal. So this expression has to equal to this base taken to that power. So that's going to be 4. So this will be then, let's just go ahead and square this and multiply by x here. This will be x squared plus 2x plus 1 is equal to 4x. Then we subtract 4x from both sides. This is minus 2x plus 1 equals 0. Okay, brought the 4x over, subtracted 4x from both sides. And then this factors into x minus 1, quantity squared, equals to 0. And then taking the square root of both sides, square root of x minus 1 is x minus 1. Square root of 0 is 0. And we get x equal to 1, which you probably could have done by inspection. But sometimes they get more complicated than that. So you have to go through this step here, these steps here. So the answer to this one is 1. And like I said, you can check it again. You put a 1 here, 1 and 1 is 2, and this is 2. The log of 2 to the base 2 is 1, because 2 to the 1 is 2. Put a 1 here, where the x is. The log of 1 to the base 4 is 0, because 4 to the 0 is 1. 1 minus 0 is 1. There's your check. Thanks for watching. We'll see you next time.